Hi everyone, this is Mrs. Terigno, and this is the second half of the Unit 14 exam review for Geometry A. So we're still talking about probability, but just so you know that you're in the right spot, this is Unit 14, page 2. Okay, the targets of a dartboard are formed by three concentric circles, and I do wish I had a little bit more space to write here. Let's see, 3 circles. Okay, and we're going to assume those circles are all equally spaced. My drawing is bad, but the diameter of the center circle is 4 inches. So this here is 4. Okay, and then they are spread 3 inches apart. So that means, let's see, that this is 3. And this is 3. So 3 here, 3 here. What is the probability the player will throw a dart into the center circle? So anytime we're doing a geometric probability, we want the area that we want over the area of the hole. So the area that we want is this little center circle that has a diameter of 4. And remember, to find area, we use pi r squared for a circle. So it would be pi times the radius there. If that has a diameter of 4, the radius would be 2. So it would be pi times 2 squared, okay, which is going to be 4 pi. And I'm leaving the pi in my answer for a reason. And then the area of the whole thing would be the outer circle. Now the radius of the outer circle would be from the center here over. And remember, we said that the radius of this inner circle was 2. So really it's like 2 and then 3 and 3. Again, I'm sorry, I wish my picture was a little bit bigger. Actually, let me try this. There we go. Okay, so the radius from here over, this is 2, and then I have 3 here and 3 here. So my total radius would be 2 plus 3, which is 8. Okay, so the radius of the inner or the outer circle is 8. So if the radius of our whole thing is 8, for my outer circle, I would do pi times 8 squared, which would equal 64 pi. 8 squared is 64. Then my pi's are going to cancel, and I'm really just left with 4 over 64. Remember, you can reduce that by typing into your calculator 4 divided by 64, getting a decimal, and then going to the math menu and hitting fraction. This comes out to 1 over 16. Okay? If you wanted that as a percentage, well, the decimal is 0.0625. So it would be like 6.25%. Sorry, I'm getting a little crowded here. Okay, so any one of those answers, 1 over 16, 0.0625, or 6.25% would all be acceptable. Okay, for number 9, another spinner question. Remember that in a circle you've got 360 degrees. So the probability of any section is just the degree measure of that central angle over 360. So section 3 here, it tells me, is 122. So my probability would be 122 out of the whole thing, which is 360. If I reduce that as a fraction, I end up with 61 over 180. As a decimal, that comes out to be 0.3388. Well, 0.3389, I guess, if I'm rounding. Oh, that's going to be a 9. And as a percentage, then, that would be 33.89%. Okay, probability on section 1. Section 1 is 26 degrees. So my probability there would be 26 out of the whole thing, which is 360. So 26 divided by 360 as a fraction would be 13 out of 180. As a decimal, it's 0.072. 0.0722, actually that 2 is repeating. And as a percentage, then that would be 7.22%. Okay, let's head down to independent or dependent. Okay, a die is rolled and then a second die is rolled. Well, the outcome of the second die really has nothing to do with what happened on the first die. So these would be independent. And for your reasoning, I would say something along these lines. So something along the lines of the outcome of the first die roll has no influence on the second die roll. That rolling the first die has nothing to do with the second one. Okay, let's go back to part B. A card is selected from the deck and not put back. And not being put back is a big thing. Without replacement automatically makes this dependent. Because depending on what card you pulled the first time, that's going to affect what you could possibly get the second time. Okay, if you would put that card back, then it would be like starting fresh. But if you don't put the card back, that means that you're working in a dependent situation. Okay, so for your explanation, I would say something along these lines. So the second card you drew depends on what you draw the first time. Okay, if you drew a club the first time, then you have one less black card in the deck. And also you have one less card in the deck, period. So that reduces your probability denominator. Okay, let's take a look at 11. Michelle and Christina are going out to lunch. They put 5 green slips and 6 red slips in a paper. If they draw a green slip, they order a hamburger. If they draw a red slip, they order a pizza. An unusual way to order lunch, but okay. Suppose that Michelle draws a slip. Not liking the outcome, she puts it back. And the fact that she puts it back makes a big difference. That makes these independent events. So as soon as she replaces it, it's independent. Okay, so the first slip, I want the probability that both draws come out green. So the first time, there are 5 green ones out of 11 total. Then she puts that green one back, so there are still 5, and there are still 11 slips in the bag. So it's going to be 5 out of 11 times 5 out of 11. That comes out to be 25 out of 121. As a decimal, it's 0.2066, which makes 20.66%. Okay? So now back in that same situation, she draws a slip and does not put it back. Then Christina draws a slip. What's the probability they both draw a green slip? So Michelle draws that first slip. So there are still 5 green slips out of 11 total. But now she doesn't put hers back. So when Christina goes to draw, there are only 4 green slips left in the bag. And because there's one missing, there are only 10 slips in the bag total. So now when I multiply this out, this comes out to be 20 out of 110, which reduces to 2 out of 11. As a decimal, 2 out of 11 comes out to be 0.1818. That actually repeats. So then as a percentage, that would be 18.18%. Okay, so it does make a difference. This time, because she did not put it back, that makes this dependent. Okay, and it really doesn't change much in your problem other than you have to remember that that slip hasn't been put back when you go to do the second draw. Okay, so this right here is the difference between independent and dependent. Okay, let's get to that back page. Okay, Mr. Monroe is organizing the gym class into 2 teams. 20 students draw cards with integers from 1 to 20. Odd numbers are on the red team, even numbers are on the blue team. Monica is on the blue team, so that tells us right away that she must have drawn an even number. And now I want to know the probability that she drew a number 10. So this is a conditional probability. I wouldn't get too caught up in the mathematics or the formula here. I want you to reason this out. If I had just asked, what is the probability that she drew 10? 10 is one of the cards out of 20, so it would be 1 out of 20. But because I know she drew an even number, that means out of the 20 numbers, her only possibilities were 2, 4, 6, 8, 10, 12, 14, 16, 18, or 20. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. So I know that she must have drawn an even number, okay, because she's on the blue team, which limits my possibilities down to 10, and then 10 is one of those 10 numbers. So now my probability, instead of being 1 out of 20, it would be 1 out of 10. So conditional probability really just limits your number of outcomes that are possible. Okay, if we're drawing a card, explain whether they're mutually exclusive or not, and explain. An ace or a 9. Well, these would be mutually exclusive because you can't be both at the same time. Okay, so for our explanation, I would say something along the lines of a card cannot be an ace and a 9 at the same time. For this next one, though, a king or a club, that would not be mutually exclusive because it's possible to be both. You could be both a king and a club if you happen to be the card that is the king of clubs. So I would say not mutually exclusive because it is possible to be both at the same time if you were the card the king of clubs. So if there's any overlap in that the king of clubs, that represents the overlap between the two categories. Okay, number 15. Trevor reaches into a can that contains 30 quarters, 25 dimes, 40 nickels, 15 pennies. What is the probability the first coin he picks is a quarter or a penny? Well, or right away tells me that I'm going to be doing addition. Okay? And these are where you have to add the two probabilities together, but you have to make sure there's no overlap that you need to subtract off later. Is it possible to be a quarter and a penny at the same time? Hopefully your answer is no. So I can just take the 30 quarters out of the total. So it would be 30 out of, let's see, total there's 55 and 40, which is going to be 95, 100, I think 110 coins. So it would be 30 out of 110 plus, so this represents the quarters, the pennies are 15 out of the 110. So total, there are 45 coins that meet my criteria out of the 110. If I reduce that fraction, let's see, 45 divided by 110 comes out to 9 over 22. As a decimal, 9 divided by 22 is 0.4091. And then when I move that decimal point, that would be 40.91%. Okay, Miguel bought 15 chances to pick the one red marble from the container to win a gift certificate. If there's a total of 200 marbles in the container, what is the probability he will not win a gift certificate? This is technically a complements problem, but I'm guessing most of you are quick enough to figure out that if there's only one red one, that means there's 199 that are not red. Okay, and if he picks any of them that are not red, that's when he wouldn't win. So our probability Oh, let's see. Okay, sorry about that. I read this problem wrong when I started it. Honestly, that 199 not being read don't really make that much of a difference. What matters is that he has 15 chances out of the 200. So there's a 15. No, I don't think that's right either. Okay. Let's start fresh with this number 16. Some of you are going to oversimplify this a little bit, and I think you're going to get the answer right because it just happens to work this way, but I want you to see why the answer is what it is. So I'm going to start by finding out the probability that he will win, okay, because that's going to be easier than finding out the probability that he won't win, okay? And if he were to poll just one time, he has a 1 out of 200 chance to win. But he gets to do it again and again and again. And I'm assuming that they would make him put the marble back in each time. So it's with replacement. I would do 1 out of 200, 1 out of 200, 1 out of 200, and so on. And that is going to happen 15 times. Okay, so this is going to go on and on and on. 15 draws total. And then, because it's, will he win here or here or here or here? Listen to what I'm saying. This or this or this. In between all of those, we would do addition. Okay? So we would want to add together 1 over 200 15 times. And when you do that, notice that the denominator will all be 200. Okay? So it's going to be out of 200. And the numerators, when you add them together, 1 plus 1 plus 1 15 times, is going to come out to 15 over 200. So he has a 15 out of 200 probability of winning. Okay, but I want the probability that he does not win. And that's a complements problem, because not winning is the complement to winning. It's the probability that this does not happen. And remember, to do those, you would take 1 minus the probability of him winning. So 1 minus 15 over 200 is really 85 out of 200. If you reduce that down, let's see, 85 divided by 200 comes out to be 17 out of 40. Oh, I'm sorry, it's 185 out of 200. That looks better. 37 out of 40, not 17. And as a decimal, 37 out of 40 is 0.925. Let me rewrite that. 0.925. And then if I slide that decimal point over, it'd be 92.5%. So there's a 92.5% chance that he will not win. Okay, so just be careful on that. I know that you want to assume it's 15 out of 200, but if there had been 2 red marbles in that jar instead of just 1, that would have changed how this setup would have worked. So remember, it's doing 1 out of 200 for each pull that he does. Okay, so you would do this 1 out of 200 plus 1 out of 200 plus 1 out of 200 over and over again 15 times. Okay, good luck with your exam. Hopefully this means you've made it to the end of your exam review experience. Make sure that you're coming in and asking lots of questions to your teachers. We will have an hour and a half before each exam next week, so if you do have questions, that would be a great time to ask. But don't wait for that time, okay? If you have questions now, ask now. All right, good luck.